Let's get a rough overview of what we will be discussing for momentum and impulses. So basically, we are going to define a new physical quantity, which is impulse. So impulse will be represented by the symbol J, and it's the average force multiplied by the period. So if you have a force being applied over a certain time period, and to be more specific, it's actually the net force being applied over a certain time period, you can calculate the value called impulse by multiplying the force and the time period. So what's important with this physical quantity impulse is that if you know that an object is experiencing an impulse of, let's say, 5 Newton second, if the object is experiencing this amount of impulse, you can know that the object is also, as an effect, the object is experiencing a change of momentum of the same amount, which is 5 Newton second. If you experience the impulse of 5 Newton second, you experience a change of momentum of 5 Newton second. You can think of it sort of like a cause and effect relationship. Last time we learned about sum of F is equals to ma. So because the object is experiencing a net force, as a result, it experiences an acceleration. So for now, for this subtopic of momentum and impulse, because an object is experiencing a certain impulse, that object, as a result, it experiences a change in momentum. So it's a cause and effect relationship over here. Okay, that's the first part of what we'll be learning for impulse and momentum and impulse. Then after that, we'll be learning that under the situation where you have an isolated system, which can be defined as the sum of external force acting in the system is equal to 0. Okay, sum of external force is equal to 0. When you have such a system, you know that the linear momentum will be conserved. When we say linear momentum is conserved, that means by the sum of linear momentum remain constant throughout the event. Okay, so the sum of momentum initial will be equal to the sum of momentum final. And if you expand it, then you have the sum of momentum of each object initial equals the sum of momentum of each object final to be equal to each other. Okay, so this is the principle of conservation of linear momentum. So that's a rough overview of what we'll be discussing for momentum and impulse. And in the next video, we'll be talking about why do we need the new quantity impulse.